Hey, welcome back, Marauders. This is video 2.8, Naming Inorganic Compounds, Part 2, Covalent Compounds. In our last video, we learned how to name ionic compounds, and this time we're going to learn about covalent compounds. Different sets of rules for naming ionic versus covalent compounds. Really important that you keep track of which one's which and use the appropriate rules. The covalent ones are going to be a little bit easier, so you've already learned the tougher ones with the ionic. A little reminder, how to tell if something is ionic or covalent. Your ionic compounds are going to be made up of one metal, that's over here on the left side of the periodic table, and one nonmetal from over here on the right. Your covalent compounds are going to be made up of two nonmetals, so two things from this part of the periodic table over here. So figure out first if what you're naming is ionic or covalent, and then name it using the appropriate rules. So your covalent compounds, pretty simple. You're going to have two words, and they're going to be using prefixes. And the prefixes will tell us how many we have. So the prefixes are mono, if you have only one, di for two, tri for three, tetra, penta, hexa, hepta, octa, nona, and deca. So you need to remember those, and that'll tell you how many of that particular element there are. For the first element in the name, you're going to write the whole name with the appropriate prefix, unless it's mono. If it's mono, you just leave that off. And then for the second element, you're going to end in IDE. So change the ending to IDE and use the appropriate prefix. So you're going to use two prefixes and two names. All right, let's look at some examples. So the first one, CO2, compound you're probably familiar with. So it's made up of carbon and oxygen. First element is just called carbon. So we'll just call it carbon. Remember the first word, we don't change the ending. There's only one carbon, so we don't need to use the prefix mono. It's understood that if there's only one of the first element, you can leave off the prefix mono. And then we have two oxygens, so the prefix for two is di. And then for oxygen, we change the ending to IDE. So carbon dioxide, compound that you guys have heard of before, CO2, carbon dioxide. Slightly different, CO. So again, starting with carbon. And this time we only have one oxygen, so we'll use the prefix mono for one, and then oxide. When you have mono and then oxide, you don't use two O's, you drop one of the O's, so it's just monoxide. This one, again, carbon. And then we have four chlorines, prefix for four is tetra. So tetra, and then chlorine is the second element. We change the ending to IDE. So carbon tetrachloride. Here we have more than one of the first elements. We have two nitrogens, so we'll use the prefix di, nitrogen. Okay, so dinitrogen, saying that there's two nitrogens. Remember the first word, you don't change the ending. And then we have four oxygens, so tetra. And then when it's tetraoxide, you just call it tetraoxide. Next one, two phosphorus, so diphosphorus. And then 10 oxygens, so decoxide. Going the other way is usually even easier. So the prefixes are going to tell us how many of each element we have. Sulfur, just one of them. And then dioxide, so two oxygens, so SO2. Difluorine, so that's F2. Monoxide, just one oxygen. Nitrogen trichloride, nitrogen and then chlorine, and there are three of them. Diphosphorus pentoxide, so we have phosphorus, two of them, then 5 oxygens. Now where it gets a little bit tricky is when they're mixed up, and this is how it's typically going to be seen. You're going to have some ionic ones and some covalent ones. So the first thing you want to do when you get to one of these problems is identify, is this ionic or covalent? And when we do that, we'll use the periodic table. Okay, remember an ionic one is going to have a metal and a nonmetal. Covalent ones will be all nonmetals. So in this one right here, we have copper and nitrogen. That's a metal with a nonmetal. So this is an ionic compound. Identify it that way first. Then use the rules for naming ionic compounds. Remember, we do not use prefixes in ionic compounds. No prefixes. So you're not going to call it tricopper. We don't do that because it's an ionic compound. This will be called copper. And then nitrogen will be, the ion will be nitride. So copper nitride. Now, copper is a transition metal, remember. The transition metals are special. They need to have Roman numerals to tell what the charge is. So you have two nitrogens, each of which has a charge of -3. You know that from the periodic table. That never changes. And then you have 3 coppers that balance out that charge. So if we have 6 negative charges, each one of these must have been +2. So this would be called copper 2 nitride. Remember, the Roman numeral is telling you the charge of each copper, not how many coppers you have. All right, N2O5. Nitrogen and oxygen, both nonmetals. So here we have a covalent compound. So we will use the prefixes this time. Dinitrogen, pentoxide. Barium and hydroxide. So this is an ionic compound. Okay, we have barium, which is a metal, so we know it's ionic. No prefixes. This will just be called barium. And then hydroxide. Barium does not need a Roman numeral because barium is not a transition metal. It always has the same charge. NH4, so you might remember that as one of your polyatomic ions. That one is called ammonium. And then SO4 is sulfate. So to name the ones with polyatomic ions, you need to remember the names of the polyatomic ions. In the previous video, there was a list of the most common ones, ammonium and sulfate, both fairly common, ones that you should know. 2 phosphorus and 5 oxygen. So phosphorus and oxygen, both nonmetals. Here's a covalent compound. We'll name it using the prefixes that we've just learned in this video. So diphosphorus. And then 5 oxygens, pentoxide. COPO4. CO is cobalt, and cobalt is a metal, so this is going to be an ionic compound. It'll be called cobalt. And then this polyatomic ion PO4 is phosphate. Cobalt, a transition metal, so just like we did up here with the copper, we need to think about what Roman numeral will go with the cobalt to tell us what the charge is, because it can vary. Phosphate, we know, has a charge of -3, and since there's just one cobalt with a -3 charge, there's one phosphate with a -3 charge, so the cobalt must have had a +3 charge to go with it. So cobalt-3 phosphate would be the correct name for this compound. The key to naming is to figure out if it's ionic or covalent first, and then use the appropriate naming rules.